Welcome to this new tutorial. Today we will be developing a small Flutter app with a login sys phrase on the Solana network. Our application will start by asking the user if they want to import an existing saved seed phrase, or if they want to generate a new account. In the second option, it generates a new phrase that is displayed on screen, so we can save it or copy it to the clipboard. And on the next screen, it asks us to create a password that we will save along with the private key in the internal storage. After validating that the passwords match, we go to the login screen, enter our password, and on the home screen, we see the public key of the wallet created along with the account balance. We can copy our public key and refresh the balance and also log out for security. On the login screen, we also have the option to enter with a different account. Knowing that we may lose access to the create account if we have not saved the seed phrase. From here, it allows us to import a seed phrase, which will be validated by the BIP30 library. And if correct, we create a new password and go to the home screen. Let's start by creating a new Flutter project with Flutter Create and the project name. We will open the pubspec file and import the following libraries. Go Route for navigation within the app, Solana to communicate with the Solana blockchain. BIP39 will help us with the seed phrase and private keys. Flutter secure storage to locally store encrypted data. And dependency read environment variables in our SNV file. We will create an assets folder where we will store our logo that we will display on the login screen. And we must define this path in the pubspec file as follows. We will also import the NV environment variable that we will create below. For this, we create the NV file in the root of the project. And we will go ahead and place our QuickNode RPC for the Solana DevNet, creating these two variables with our PC address. And in one of the variables, we will modify the HTTPS for WSS. We will use RPC when connecting to the network on the home page. Now go to Android app, open build Gradle file, look for this line, main SDK version, and replace this value for the number 23. In the main Dart file, we will replace everything below the main function with this material app. And we will declare the router class from the router library where we will define our routes. We will create the file for each of the screens that our app will have. We will create a pages folder with the files. Login. The first screen that is displayed if an account is found stored. Set up account. Here, we configure a new account, either by importing a seed phrase or creating a completely new one. Input phrase. Screen to import a seed phrase. Generate phrase to generate a new seed phrase. Set up password to create our local password. And home, the screen where our application lands after the login process is successful. For each of the pages, we will create stateful widgets with a name that refers to the screen we are creating. In the setup account page, our widget can be stateless. Now, in the main file, we can easily define the routes as follows. A name for the route, and then we will return in the builder each of the widgets we have created, and thus we will have access to all the pages from anywhere in the application through the Go Router library. In the password route, we will create a parameter private key, like so, and we will define inside the class constructor. We go to the setup password file and define it in the same way. We do this so we can receive the private key that we need to store locally, and we will do it when we have the password ready to save both data and memory. Let's create our login page. We place a scaffold with a column in the body as follows. Here we will first place our QuickNode logo as the application logo, then the login title, and then a form to handle the key entry. We must declare this form key at the top, and we place the rest of the elements in the columns. First, the text input field, which uses this password controller And in its validation function, we will verify if the entered password corresponds to the one saved in internal storage. Otherwise, it changes the state of this bool validation, failed, and it interrupts the validation function. But if it is correct, it continues to the home route, logging in successfully. We make the declarations of the variables we are using. Now we place this text invalid password. That will only be shown if the validation failed flag is activated when validating the text input field. And we create the login and use a different account buttons to allow the option to import a new account by deleting the data stored in storage. We will create the onSubmit function, which will only consist of validating the form. And the onDifferentAccountPress function, where we will display an alert message, where it is announced that the account data saved on the phone will be lost. This box will have the cancel buttons that will close the alert and return to logging. And the OK button to go to the setup route, where we will create or import a new account. It would be left to try to load the data from the phone in the initial state, calling a function check for saved login that will return a bool credentials found. If this comes back false, we redirect to setup before any interaction with the user. And if it is true, we change the state of this variable loading to false. This serves to display a progress bar while reading storage. In this way, our check for save login function reads the field's private key and password from internal storage and returns false if it fails to read either of them and true if both data saved. Remember that we will use the password to verify logging. We include the key and storage declarations, and our login page is ready. Our setup account page will consist of just a couple of buttons. One for I already have a seed phrase. That takes us to the input phrase page. And the other button I want to generate a new account, where we navigate to generate phrase. Let's create the input phrase page. We place the title, enter your seed phrase. And then we make a form consisting of a grid, which is inside a 300 by 400 size box. Our grid will consist of a list of 12 text input fields. And each will display the index number of the list, indicating the order of the words. In the onSave function, we will save the contents of each of the fields in the list in the words array, which will contain the seed words. Further down, we will display the message invalid phrase in case we enter an incorrect phrase. Otherwise, it shows an empty space. And a continue button that will trigger the onSubmit function that we will create. This function calls the validate function of the form, and if it proceeds, it calls the save function to save all the fields, the list of words into a variable word string. And this list will validate with the validate mnemonic function of the BIP30 library that we must import. We will also declare this bool validation failed. Then our BIP39 library verifies that our secret phrase is valid. We will navigate to the password setup root and send the string word string as a parameter with the seed phrase. And if the verification fails, we change the corresponding variable to true, so the UI will display the message invalid phrase. And now we will create our generate phrase page, which will consist of a scaffold with a column, and we display a message saying we should store our seed phrase securely, otherwise we will not be able to recover the account. Then we will create a column that will carry the secret phrase that we will generate in a function that we will create below. Below the secret phrase, we'll place an icon to copy the content of the secret phrase like this, and when pressed, we will change the icon. We must declare this icon and now show how the secret phrase is generated. In the initial state of our screen, we will call the generate mnemonic function. This function will simply call the generate mnemonic function of the BIP39 library that we must import, and then save it in our mnemonic variable. We'll now place a checkbox with the phrase. I have stored my seed phrase. When pressing the checkbox, we will change the copied variable to true. And finally, we will place the button that will show the go back message. If the copied variable is false, which is its default value, and when pressed navigates to the login route, and if the copied bool is true, the button displays the continue message. And when pressing it, we will navigate to the setup password route with the seed phrase as a parameter. Our setup password page will simply consist of a form, for which we will declare a form key. We will also declare two controllers of text editing controller type. Within our form, we will have a column with the two text input fields. The first for the password and the second for password confirmation. In the validators of both, we require that some password be entered. Here we can implement any other condition that we want to place on passwords, such as number and type of characters, etc. To validate the second field, we need both values to match. Finally, we place a submit button that triggers the submit function. This function will first validate the form. If the passwords do not match, the function is interrupted. Otherwise, we will create a keypar with the secret phrase. For this, we will use the class that we import from the Solana library, ed255hov keeper, and it's from mnemonic function, which receives a secret phrase and from there generates a keypair class. Remember that our setup password class receives the secret key as a parameter, so we will have it available through widget.private key. In our implementation, we will not save the secret phrase in storage, but we will save the private key that we can access in our keypair variable in its parameter address. And now that we have our password and our private key, we save them in storage with the names password and private key, through which we can access these values later, and we navigate to the login route. This time with the data saved in storage, let's not forget to declare our storage variable and import the corresponding library. We just need to create our homepage. We will create a scaffold with a list that will contain 3 card widgets. In the first, we display the public key of our account. We will read this from internal storage in a function that we will create in a few moments. We display the loading message while this public key variable is in its default null value. While the storage is being read, we also place a button icon to copy the public key to the clipboard. Our second card will carry the account balance, similarly to the address, through a balance variable that we must declare and whose value we will obtain by interacting with the blockchain. To do this, we need a client on the network initialize with a function that we will create below. But first, we will finish our UI with the last card that will carry the button to log us out. In this case, we will simply navigate back to the login page when pressing the icon on this card. In this way, we must re-enter the password to enter this home page. In the initial state of our page, we will call the read private key and initialize client functions. In our first function, we read from storage the key private key. If we find it, we decode it to convert it into a byte list. This base58 decode function that comes from the base58 library that we easily import as seen on screen. And from there, we get our public address with the ed25519HD public key from the Solana library, passing it the byte list. We save this public key in the public key variable to display on screen. The initialize client function first reads our env file through the .env library, which we must import. And then we create our Solana client with the Solana client constructor, and in the RP curl and WebSocket URL parameters, we introduce our QuickNode RPC that we have available in the env file, like so. Then we call the getBalance function. This function simply sets the balance to null so that the UI displays the loading message while interacting with the network. Then we will get the balance as follows, with our client already initialized and the getBalance function for our public key, and after obtaining it, we save it in our balance variable. To avoid null checking issues, we can also call the initialize client function once we have the public key available, moving it from init state to the read private key function. Let's do Flutter run and test the functionality of the app. Correct some correct routes, like the image file route, and copy the public address of our created account and get some definite Solana sit install files. See how when updating, we can see the balance on screen correctly. You reached the end of the video. Feel free to download the repo and add your own functionality. Please like and comment if you need any help with this repo. Until next time.